Hello class, welcome to Unit 4, Data and Probability. We'll be starting new stuff here. So the first thing we'll look at is the simple probability, which is just the ratio of number of favorable outcomes to the total number of possible outcomes. So you can often see this as just a simple fraction where the probability of the event is the number of your favorable divided by the total number of outcomes. Now, a couple other things to consider before we kind of write these up is it a compound probability, which is the probability of two events occurring. Now, even when we look at the two events, this could refer to things like independent, dependent, mutually exclusive, or the overlapping events. So when we look at this, the independent event is going to be talking about the first one does not increase or decrease the probability of another event happening. So the two things would be separate. So this is often going to refer to things like rolling a dice twice, or if we are pulling stuff out of a deck of cards, we make sure we put the card back in. Or if we're going to pull marbles out of a bag, all of the marbles go back in. So basically the same thing, when you do your two or more events, they end up back in there. When we look at a dependent event, this is going to influence the probability of the other event. So this would be like once you take the card out of the deck, well, now there is one less than the prior. Or the same thing with marbles. When you take a marble out and you try to take a second grab, there's going to be one less than the prior one. So that's what we're looking at with those two. So when we look at independent events, we can also look at a lot of times the and or statements. So when we look at the and statements, a lot of times the probability of the event is going to be the probability of A times the probability of B. When we look at an or statement, your probability of your event is going to be the probability of A plus the probability of B. When we look at dependent events, the one thing here we need to consider is also whether it's and or statement, but we need to figure out, well, what is the probability of A? But that's going to affect the probability of B. Especially if we are, like I said, replacing them. So typically that ends up with a statement that would be like -1 after that. Mutually exclusive events are going to be things that can't happen at the same time. So if you're looking at, like a deck of cards, this is going to be like the probability of saying, what is the chance that I roll or pick a red card and a black card? Well, that's impossible because there's only red and black. Or what's the chances on a dice of me rolling an odd and an even number? Well, odd and even are not the same. So mutually exclusive events, things that can't happen at the same time, when we look at basically say A and B, this is going to have basically a 0% chance of happening. We also need to look at things like overlapping events. Likewise would be things that have the same outcome. So if you're looking at like what are the chances of it being a face card and red, well, there are some overlap in those. If we look at trying to say what are the chances of it being greater than 4 and or even, now there is some overlap there. So we have to look at these events where basically we're looking at, well, what's the probability of A times the plus the probability of B minus the probability of A and B. So again, that would just be like your probability of A plus your probability of B. But then we got to basically subtract out the overlap. Now, in a probability, we should be ranging anywhere from 0 to 100% chance of happening. When we look at a theoretical probability spectrum, it should be coming up between 0 and 100. So these are actually a lot easier than what we think, what that may have sounded. So let's look at a few examples here that if you have a spinner that has 20 equal size sections from 1 to 20, and you want to find the probability that you spin a 2 or 5. Well, if you're looking out of 2 and 5 out of the 20, and we think about our equation where it's saying favorable outcomes, there are 2 favorable outcomes out of the 20. So really what we're looking at is a 1 in 10 chance. So that's our probability of picking a 2 or 5. When we look at the probability that you spin a number that is a multiple of 2 or 5, well, if you look at the first list, that's your probability of 2. So that would be like your 10 out of 20. If you look at your probability of 5 out of 20, or the multiples of 5, that's 4 out of 20. But the thing we need to recognize here is there is some overlap. So when there are some overlapping numbers, we need to make sure essentially that we get rid of 2 of those possibilities. So when you look at this one, this is basically telling us that 2 out of those 20 chances isn't going to work. So if you kind of go back and count, well, what's 10 plus 4 minus 2? That's a 12 and 20 chance. If you look at all of your options, we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, we would look at 12 out of 20, and that would also be a 3 and 5 chance. If we look at the probability of spinning a number that greater than 10 or even, we need to look at the same thing. So think about listing amount. So if you think about the probability of 10 greater than 10 or 20, all right, so greater than 10, well, that wouldn't include 10. So we got to think about 11 through 20, and that's really just a 10 out of 20 chance. So like basically a 1/2 chance. If we look at the evens, again, that should be a 10 out of 20 chance. The problem here is if there's some overlap, once we get above 10, well, now we're looking at 12, 14, 16, 18, 20. So we are looking at 5 of them that we would have done twice that we need to get rid of. So what we are looking at here is really thinking about, well, what are all my numbers if I count them up, getting rid of them? Well, 10 plus 10 is 20. 20 minus 5 is 15 out of 20 chance. So we could look at this as basically saying 3 out of 4 times we should be able to spin either a 10 or an even number. So now we're going to be looking at a standard cube, which is 6-sided. So if we look at the probability that you roll an even number or a number less than 4. Well, if we look at even, that would be basically 2, 4, and 6. So that would be a 3 in 6 chance. Numbers less than 4 would also be 1, 2, 3. So that would be a 3 in 6 chance. And then remember, because there is some overlapping numbers, we would need to subtract out 1 out of 6. So really, if we think about even numbers, that's going to end up being a 5 in 6 chance. The other way to kind of get this answer is if you think about it with all of them just saying, oh, even or less than 4. Well, less than 4 would be these, plus your 4, 6. Well, the only one that would not work would be 5. So we could also kind of derive that without having to add up these fractions. If you find the probability of that you roll a 2 or an odd number, again, the same thing can kind of work when you look at your 4, 5, and 6. 2, 3, 4, 5, 6. Rolling a 2, well, that's a 1 in 6 chance. And then your odd numbers are going to be 1, 3, 5. So that would be a 3 in 6 chance. If we look at the chance that it's a roll of odd or even, well, that's going to make us 4 and 6. Because now we're looking at there's no overlap of those numbers, so essentially we'd have to subtract 0. So if we're looking at trying to roll the 2 or the odd numbers, that looks like 4 out of 6, which we could simplify to 2 out of 3. All right, suppose you roll a red number cube and a blue number cube, so we're rolling 2 different cubes. Find the probability that you roll a 3 on the red and an even number on the blue. Well, if we think about the probability of each of these independently, a 3 on one dice would be 1 out of 6. An even on the other would be 3 out of 6. So we could maybe just say that's 1/2. But the probability that it's red on the 3 and blue, well, that means both of them have to end up independently. So this is where we do the probability of 1/6 times 1/2. So this would be 1 out of 12 chance that we get those numbers. If we use the same cubes and find the probability that you roll a 5 on the red cube and a 1 on the 2 on the blue cube. All right, pause here and try that. So hopefully we came up with the probability of a 5 was 1 in 6. And on the red cube, 1 or a 2, well, that's 2 out of 6. And then we multiply them together to find out 2 out of 36 would be a 1 in 18 chance. Okay, you may pause here and try a 5. Otherwise, we'll get solving. So if you have a standard deck of 52 cards and a coin, so again, 2 different independent events, but what's the probability of picking a diamond and flipping a tail? So hopefully we understand that there's 4 suits in a deck of cards, one of which is the diamond. And if we are flipping a card or flipping a coin, that would be a 1 in 2 chance. But the chances of both of them happening, multiply that together, would be 1 out of 8. Find the probability of picking a king and flipping a head. Well, if we're going to do a king, there are 4 of each out of a total of 52 times 1 out of 2, because you have 1 of each suit for that. But then we can look at this. Now, easier to kind of do these in your head if you simplify first. If not, plug them into your calculator, and we should end up with 1 in 26 chance of both them happening. Okay, example 6. You choose a tile at random from a bag containing 5 X's, 7 Y's, and 8 Z's. You replace the first tile and then choose again. What is the probability you choose a X tile and then a Z tile? So these are going to be, again, 2 different events. But the key here is they're saying you do replace it. So that means when we look at our first possibility of an X, well, that was 5. Well, what's out of that 12, 20 of them? So the first chance would be 5 out of 20. But then you put it back in, so when you look at your Z tile, now we're looking at 8 out of 20. So now we can kind of multiply these out, and that's really 1/4 times 2/5, which is going to make this a little bit easier. It's going to make this 2 out of 20, which really could simplify to 1 out of 10 chance. If we're using the same bag and you choose back-to-back Y's, well, that means the first one's 7 out of 20. The second one would be 7 out of 20 because we are putting it back in. That would be 49 out of 400 chance. Okay. And then lastly, maybe try this one. Pause here and try this. Okay, the key here is it's saying you don't get a blue. So that means it's going to be 7 chances of not blue out of your 11 total. And then it's saying doing that both times. So 7 times 7, 11. 49 out of 121 chance. So using the same bag of marbles, you pick 1 marble out without replacing. So now we are not replacing. So this is going to be one of those situations where it is dependent upon the first one, and we will have to kind of recalculate a second probability. So if you look at the first possibility of picking 7 out of the 11, well, then the second possibility is automatically going to be out of 10 because we're not putting it back. And then what we're assuming here is that if we don't get a blue on the first one, well, that means there is one less up top as well. And then we can use our calculation from there to basically say that's 42 out of 110, which will simplify to 21 out of 55 chance. If we start with a standard deck of 52 cards, what is the probability that you randomly select the queen, and then without replacement you select the jack? Well, the first thing would there would be 4 queens, so that would be out of 52. But when we look at jacks here, again, that's automatically going to be one less card in the total. But because we decided to pick a jack the second time, the jack wasn't affected by the queen. So there would still be 4 of those left, which when we want to look at solving and multiplying, we get the 16 out of the 2652, which would be able to simplify to a 4 in 663 chance. If we have 1 freshman, 2 sophomores, 4 juniors, 5 seniors, receive top scores in the school essay contest regarding the district homework policy, to choose which 2 students will read their essay at the school board meeting, 2 names are chosen at random from a hat. Find the probability that a junior, then a senior are chosen. So if we look at probability that you find a junior, well, that would be 4 out of our total 12. And then a senior, which would be, well, that's times a 5. But remember, the second time around, we only have 11 people left. So looking at this, that would be 20 out of 132, which we could simplify to 5 out of 33. Find the probability that freshman, then a junior are chosen. Well, freshman, it was only 1 of those. So if we get that freshman on the second shot, we now only have 11 to get our junior. So 4 out of 11, that would be 4 out of 132, which would simplify to a 1 out of 33. And then lastly, find the probability that a sophomore, then a senior. Well, sophomore was 2 out of 12. And then a senior would be 5 out of the 11 remaining. So that's going to make us have a 10 and 132, which could simplify to 5 out of 66. All right. Same thing's going to apply here when we now add an extra element. If you have a bag of marbles that has 4 yellow, 8 red, and 10 blue, you select 3 marbles in total, and each time you do not replace the selected marble. So when we look through each of these, the first thing we're going to be looking at is how many marbles are there. So that looks like 22. So we're looking at 8 out of 22 for red. And if we're taking each one out, assuming that we picked a red, so if we got 8 out of 22, now we're looking at 21 left. Well, the red did not affect the blue, and the blue did not affect the yellow. But we are taking 1 less marble out each time. Take a minute to multiply that up. You get an 8 out of 231. Find the probability of choosing all blue marbles. Well, that would be start with 10 out of 22. Now again, assuming that we drew a blue, that would make that 1 less. And choosing another one, that would assume that that is going to get smaller as well. Take a minute to multiply these all up. Looks like we will have a 6 out of 77 chance. If we look at choosing a yellow, well, that's 4 out of 22. And then 2 red, well, that means the next one would be 8 out of 21. But if we get red, that will also drop one out there. So that would leave us with times 7 over 20. So again, let's multiply these up, which looks like that would simplify down to a 4 and in 165 chance. Okay, hopefully that'll help give a little insight and review into some of the probability things that you've done in the past. All right, good luck.